everyone. Welcome to our very first lesson in basic calculus, the limits of algebraic functions. This is Miss Chen, your learning buddy, and I look forward that you will excel in your studies. In today's lesson, we shall explore the meaning of limits through its graphs and table of values. We will also discuss the laws governing limits. Be ready with your scientific calculator and graphing application because it will make the process easier. First, let me share with you a story. Attracted by the beauty of Kitinday Underground River in Huveliar Albay, John and his friends had an exciting adventure before the pandemic. They have hiked a rocky trail to reach the spot where they could have a good dive. But when he was about to jump, he can only stay just near the edge because of the sudden danger he had perceived. This feeling gave him an experience of limit. In the same manner, we try to understand the limit of a function in x as x approaches a certain value. In symbols, we have the limit of f of x as x approaches to a. This is read as the limits of a function in x as x approaches a certain value. Let's say our function is f of x equals x plus 1, and that certain value is 3. Mathematically, we write it as the limit of x plus 1 as x approaches 3. Looking at the graph, we consider that portion at which x is equal to 3. This point, having coordinates 3, 4, then divides the graph into 2. The right portion and the other as the left portion. Take note that we may start from the left or right in approaching x equals 3. Take a look at the arrow as x approaches 3 from the left. The function f of x approaches to 4. In symbols, this is the limit of x plus 1 as x approaches 3 from the left equals 4. On the other hand, as x approaches 3 from the right, take note that the function also approaches to 4. In symbols, we have the limit of x plus 1 as x approaches 3 from the right is 4. Since the two sides of the function approaches to the same value as x approaches 3, we therefore conclude that the limit of x plus 1 as x approaches 3 is 4. Let's verify our conclusion through a table of values by evaluating the function with appropriate values of x. Let's have first the left-hand side of the limit. In symbols, we have the limit of x plus 1 as x approaches 3 from the left. In this case, consider only the values from the left of 3. For example, we choose 2. Evaluating the function, it will result to 3. If we will choose 2 and 5/10, evaluating f of x when x is equal to 2 and 5/10, we will have 3 and 5/10. Do the same process for each chosen value. As much as possible, we have to choose a value from the left side of 3 that is much closer to 3, such as 2 and 99,999,999 millionths. Evaluating the function, it will yield to 3 and 99,999,999 millionths. And if we choose a number that is much closer to 3 from its left, the value of the function gets closer to 4. Therefore, the limit of x plus 1 as x approaches 3 from the left is 4. We do the same as we evaluate the limits of x plus 1 as x approaches 3 from the right. We start with x equals 4. Evaluating the function at x equals 4, we will get 5. Now choosing a number that is much closer to 3 from the right, we will arrive at a much closer value to 4. Hence, we say the limit of x plus 1 as x approaches 3 from the right is 4. Notice that if we choose a number that is much closer to 3 on either side, we have arrived at a value that is much closer to 4. Since the limit of x plus 1 as x approaches 3 from the left is equal to the limit of x plus 1 as x approaches 3 from the right, we conclude that the limit of x plus 1 as x approaches 3 is 4. This supports our answer when we have considered using the graph of the function f of x equals x plus 1. In this example, the limit of f of x as x approaches to a is just f of a. With this, we can get the limits of the function either using graph of the function or using the table of values. From this, we can have the following key points. First, the limit of a function f is a number L that the values of f of x approach as x approaches a certain number a. It is written as the limit of f of x as x approaches a equals L if it exists. Second, the limit of f of x as x approaches a exists and is equal to L if and only if the limit of f of x as x approaches a from the left is equal to the limit of f of x as x approaches a from the right, which is equal to L. Lastly, we can evaluate the limits of a given function y equals f of x by using either tabular method or graphical method.